God, those 7th period kids' class smell so bad.
Hi, Jamal.
Yeah, the jokes before we start. Anyway, so 5th and 7th, I just passed back their test, and we went over it. So we're already about halfway through the period here. You guys will get yours back. 5th will get yours back tomorrow. 7th,
in front of the camera.
7th, I don't know when you'll get yours back. It'll be a long time. Next time I see you. I think it's Wednesday the next time I see you. Tomorrow we got another game.
Game.
Where?
Here at home.
Royal?
Yeah.
What time do we get out?
1:45. All right. Let's see, we started last week with the imaginary numbers. Remember that? What does I equal?
Negative square root.
Square root of
A negative.
-1.
Oh, yeah.
That's important because we'll use I squared. What's I squared equal?
Square root of -1. Yeah.
Yeah, what's the square root of -1 squared? -1. Yay.
That's what you get it.
That was Linda. Linda, you're terrible. Anyway.
This sub's gonna be like,
Mrs. Frank. And Mrs. Smith. So we got this. And then we used it for when we did quadratic formula. If you remember correctly. So all we're going to do today, just refresh your memory, we're just going to do quadratic formula. And they will all have imaginary answers.
boo.
Yeah. So if I'm like y equals 3x squared minus 2x plus 3. And I say find the zeros. What's that mean? Have we used that word before?
Nope. No.
Find zeros. It's kind of like x-intercepts. Because zeros just mean find the values of x that will make y 0. Which 99% of the time means x-intercepts, right? When y is 0 is where it crosses the x-axis. But for these, like this parabola, will not have any x-intercepts. But there are imaginary numbers that I can plug in that will give me an answer for 0 for y. That's why it's not. That's why they're technically not the same thing. Anyway, but you could just think of it as x-intercepts. I do still. So how do we find our x-intercepts for this?
Plug in.
Plug 0 for y.
Plug in 0 for y, solve for x. 3x minus 2x plus 3. And then
Quadratic.
Subtract 3.
Oh yeah, quadratic.
subtract 3. How's that going to help?
Oh, never mind.
Quadratic.
Quadrat. Well, what about factoring?
You can, but it'll be
Yeah, spoiler alert, it's not factorable. All right. So, you could try, but it's not going to happen. So quadratic formula. Anyone have it memorized?
Nope.
Let's see.
It's
Oh,
like
b
minus b
plus or minus square
one
root
at a
of,
time.
Yeah, one.
A, C divided by 2A.
sisters.
Anyone have a song or anything? Negative b. Remember that song?
Yeah,
Oh,
that's really
square
quadratic.
root. Oh, I forgot the square root. All right. It's okay. 5th and 7th period, they know that song. So they're like, oh yeah.
Oh, they do?
Yeah. Anyway, so we just plug them in. Do I put x's in there?
Nope.
No, you don't put x's in there. You just put the numbers in. So we got A, B, C, do it.
It's up there, right above you. Okay.
I would normally give you time. Oh yeah, I'll give you time.
Awesome.
Okay, try it. 5th and 7th, you try it too.
7.
What are we trying?
Wow. Yeah.
I was looking over here.
Shows how weird you think.
Shut up.
So rude.
They're gonna be like, wow, they love you, Taylor. I feel love in that third period class.
Make sure you're putting +2.
You mean to freeze that? No.
Well, this is the test I failed.
I think it's not. We just started Friday. I'm trying to refresh your memory here. B squared is 4.
We're gonna have to use measuring numbers, right?
Yes.
What's the square?
Isn't that near?
Should have at least have that.
Question. Square.
Were you here Friday?
Yeah.
I was too, but I still don't understand.
I still don't understand.
It's confusing.
So now we simplify. We start underneath. The 2 is just going to be hanging out there, 2 plus or minus. Well, we can do the bottom. 2 times 3 is 6. All right. Now we simplify under the square root. So we're going to have a 4. Now we have to do 4 times 3 times 3. What's that?
36.
Negative.
30.
Yeah, it's minus 36. All right, there's only one negative there. Negative 4 times 3 is negative 12. Negative 12 times 3 is negative 36. So 4 minus 36, I have 2 plus or minus the square root of negative 32 over 6.
No.
There used to be no solution, but as we learned Friday, we can now come up with solutions that will work.
Wait, is it?
It's A.
Okay, you have to go back to
It's 32.
like October, I think is when we did this.
Holy crap.
When we were simplifying roots, simplifying the radicals.
Oh, you moved it down.
You write that down here. So just, I'm going to just do this little piece right here. The square root of negative 32. Remember when we broke it apart into the factors? Like 2 times 16, 2 times 8, 2 times 4, and then whenever, if I have 2 of them, I bring out 1, right? Remember all that?
Yeah.
Oh, yeah.
Same thing. It's just now the only difference is, with the negative, the first step is always the square root of negative 32. Well, isn't negative 32 the same as 32 times negative 1?
Yeah.
Yes.
Was it the I?
And negative 1 is equal to I squared, isn't it?
Yeah.
Yes. So now we have 32 times I squared under the root. Well, now it's just the same as before as we did in October. You do simplify out the 32. So you do your 2. I think most of you did it this way. There's a couple different ways of doing it.
Yeah, just keep it this way.
Keep it that way.
And you gotta pull
If
2
you're
out.
if you're cool, you can stop right here. You can go 2 times 16. Oh, square root of 16 is 4. Bring it out. What if you're not cool? It's okay. You can do the long way. Here. Every pair of 2's, bring out a 2. There's another one. Times 2. Square root. That 2's left inside.
Times I squared.
Well, what is the square root of I squared? Or you could even do this. You can do I times I. Oh, hey, there's 2 of them. Bring out 1.
Oh, duh.
So now, we have 4, and I actually wrote this wrong. It should be 4 root 2 I. Always just write the I at the end, in the back.
Oh,
Yeah.
and it's not in the parentheses.
Wait, I thought it was supposed to be next to the 4.
Plus or minus.
No, that's what I said. Just put it at the back. Right at the end.
Like leftovers?
It's just more proper. It's not wrong to write this. That's still correct. This is just more normal. More, what's the word I'm looking for?
Human.
It's better. Proper.
Sure. That's not the word I was looking for. That word. It's this. Oh my God, I can't think of it. It's the way they do it in math. It's like we don't write x2, we write 2x.
It's a regular way to do it.
Yeah, what's that called? This French. I know you're just thinking of the word I'm looking for right now, the English. Nope, I don't know. Anyway, so we got 4 root 2i. That was just for this, right? That was just the square root of negative 32 is equal to 4 root 2i. Well now, it's okay. We got 2 plus or minus. I'm just going to rewrite it with this. 4 root 2i over 6. Divide both of them by 6 and you're done. What's 2 divided by 6? 1/3 is correct. And 4 root 2 divided by 6. Now it's a little more complicated. Only slightly.
5.6.
All you do is you divide the number in front of the root by the 6. So 4 over 6 is 4/6, which is 2/3, right? So you could either write, 2/3 root 2i. That's kind of weird. Or you could write it as 1/3 plus or minus 2 root 2 over 3i. That's the best way. I just reduced 4/6 to 2/3. Dude, I divided both numbers by 6.
just did the whole.
There's so many steps.
I was like, I just did quadratic formula. We practiced quadratic formula on Thursday last week. You're going to get a negative under the square root every single time today. Simplify it.
Is there always going to be a
Divide them both by the bottom number. That's it. What?
Is there always going to be an
Today you have 4 problems to try. They will all have imaginary answers.
They better not, later on, they better not.
Are they all going to be I squared?
Yeah, it'll always be, every one you do, you're going to do quadratic formula. You're going to get a negative under the square root. You're going to have to simplify it and divide them both by the bottom number. That's it. Some of them will work out nicer than that, though. That's kind of ugly.
For doing imaginary numbers, why can't we help us end up doing the square root of 232 and then it's putting an I on the back of it?
You can. That's a good point.
Is this a lot?
I showed all my work here. Whenever you have the square root of a negative, just ignore the negative and put an I at the end. And do the square root like you normally would. That's what it turns out being. Yes.
Wait, so what do you mean, dude?
He said, that was so much easier. Why didn't you just tell us that the first time?
Yeah.
Watch out.
What did you tell us when
Yeah.
When you have the square root of a negative, you don't have to do the I squared thing. I mean, just know that it's going to be, like, for example, if you got the square root of negative 16, just ignore the negative. What's the square root of 16? 4. So it's 4i. Whoops, that was a bad shot. 4i. The square root of negative 100. What do you think it is?
10.
10i. That's it. I was just showing you why the I is there. Because the negative 1 is I squared, and then you do the square root of the I squared, and you get the I.
Oh.
So like the square root of negative 8. Well, it's square root of 8 times I, and then you have to do your thing with the 8. Which you guys were all masters of this back when we did it. So it'd be 2 root 2i. So it's the exact same thing as what we did before. Just now you're throwing an I at the end. That's the only difference. Whatever you have a negative. Yeah, that's it. What enough?
Wait, so what's the point of this?
Fighting the zeros of quadratics. What?
Finding the zeros of quadratic.
Yes. We're working with imaginary numbers. Remember I told you imaginary numbers, they're used in electronics.